Integration lecture 3. This includes volume. Now, normally your volume is based on multiply by pi. That means integration with what? Limit. But each of the expression or each of the equation will be squared first. That means your equation of the curve that will be represented through y will be squared, then it will be integrated, then the limits will be applied, and then the answer will be multiplied by pi. So if you have gone through lecture 1 and lecture 2, you will be easily able to understand the volume concept here. That means your equation when rotated with x-axis 360 and the examiner asks for volume. The examiner asks for volume. So what we need to do is we will always square the equation of y with limits, integrate with limits, and then multiply by pi. Whereas if the same thing would have been that equation rotated with y-axis 360. In this case, your volume will be pi integration with limit, but now you will be doing x square. That means from equation of y, you will make x the subject, and then with the respect to the equation of x, your x equation will be squared, integrated with limits, and then multiplied by pi. So we can just understand this with few example questions. So here's the question from November 2001, paper 1, question number 10. A curve has an equation of y is equal to x square plus 2 upon x. Find the volume of the solid when region enclosed by the curve x-axis. Since x-axis is there, we will obviously be squaring y. The line x1, so the lower limit is 1, the upper limit is 2, is rotated completely with what? X-axis. Now you need to understand that since it is rotated by x-axis, your volume will always be pi, your integration with upper limit, lower limit, and you will be doing y square. So in this regard, what we need to do is volume is equal to pi. Your upper limit is 2, lower limit is 1, and your y is basically x square plus 2 upon x whole square, which will be right dx. To open this, you need to understand one particular thing, and that thing is that this thing will be opened as a plus b whole square, which means a square plus 2ab plus b square will be used in this. That means this will be used through the identity. That means x square plus 2 upon x whole square will be used as x square plus 2 x square 2 upon x plus 2 upon x whole square. So when we open this thing, this will be looked upon as x to the power 4 plus square and x is cancelled plus 4x plus 4 upon x square. This will be integrated then. This will be integrated. That means that the entire equation, that means whole square, will be opened as what? X to the power 4 plus 4x plus 4 upon x square. So let's just open this up directly through the normal form, and that is that using what? Using the identity, which will be volume is equal to pi integration of upper limit 2 and lower limit 1. This will be x to the power 4 plus 2, 2 is 4, x and x, so this should be 4x plus 4 upon x square dot dx. Now, integrating this should be volume. We'll be obviously, when integrated, we'll be looking forward for the modulus sign. This should be x5 upon 5 plus 4x square upon 2. Now, obviously, this x square, since it will go in the numerator, 4 upon x square, this will be written as 4x negative 2. When integrating this thing, this should be 4x negative 1 upon negative 1. So that means this should be 4 negative 4x negative 4x. So we need to write this thing as negative 4 upon x, and the upper limit should be 2 and the lower limit should be 1. The upper limit is 2 and the lower limit is 1. Now, in this case, what we need to understand is we will be applying the upper and the lower limit. Volume is equal to what? Pi. This should be 2 5 upon 5 plus 4 2 square upon 2 minus 4 upon 2. Whereas this entire thing should be subtracted by 1 to the power 5 upon 5 plus 4 1 square upon 2 minus 4 upon 1, and this thing will come under the modulus sign. When solving, 2 to the power 5 plus 4 2 to the power square upon 2, which means minus 4 upon 2, 2 and 2, 4 and 2 will be cancelled. We'll be having what? We'll be having the answer for this will be 62 upon 5 minus, and this will be minus 9 upon 5. But this thing should be multiplied with pi. And since obviously we have negative sign, so what we're going to do is 62 upon 5 plus 9 upon 5 will be used. And then we will end up having the pi value. We have 5 and 5 in common. This should be 71 upon 5. So the end result that we will have is 71 upon 5 pi. So let's just attempt another example question. This is from November 2006, paper 1, question number 8, part 3. The question clearly says that equation of the curve is y is equal to 6 upon 5 minus 2x. The region between the curve, the x-axis, the line 0, x is equal to 0, x is equal to 1, is rotated 360 with x-axis. When it is said x-axis, the y will be taken into consideration. Show the volume obtained is 12 upon 5 pi. So can we say that volume is equal to pi integration upper limit lower limit y square, because it is rotating with the x-axis. So we have volume pi, your upper limit is 2, your upper limit is 1, and your lower limit is 0, whereas 6 upon 5 minus 2x, this will be applied whole square dot dx. So with this thing, what we can see is that since square is applied, we can say 1, 0, your 6 square will be 36, whereas 5 minus 2x will be used as whole square dot dx. When we need to integrate whole square, we can take the bracket on the top in the numerator. That means 1, 0. This should be 36. 5 minus 2x to the power negative 2 dot dx. Now we need to integrate this. So this should be pi. Obviously, pi will be there. When integration, this limits going to be used under what? Limits will be used under the modulus sign. So we can say negative 2 will become what? 36 5 minus 2x to the power negative 1 divided by negative 1 into differentiation of the bracket, and the differentiation of the bracket will be minus 2. So minus 2 will be 2. Minus minus is cancelled. 2 ones are and 2 18s are. Your upper limit will be 1 and the lower limit will be. So if we just simplify this should be pi 18 upon 5 minus 2x. Your upper limit is 1 and your lower limit is 0. You need to understand this, that in this particular case, when we were integrating this, 36 5 minus 2x to the power negative 2, we introduce plus 1. So negative 2 plus 1 becomes negative 1. We divide it by negative 1. And the differential of the bracket is when we have 5 minus 2x, we have minus 2. In the differentiation, we multiply this. In the integration, what we do is we divide. Negative, negative cancel. 2 ones is 2. So this should be 36 divided by 2. 5 minus 2x to the power negative 1, 18, 5 minus 2x to the power negative 1. So this negative 1 to make it positive, we obviously reciprocal the bracket to the denominator. So now considering the impact of the limits, what we need to understand is we will apply 1 and 0. So if we just say volume pi 18 5 minus 2 1 minus 18 5 minus 2 0 modulus close. So we end up having what? We have pi, the first bracket answer will be 6. The first bracket answer will be 6, whereas the other bracket answer will be 18 upon 5. So that means 6 5 becomes what? 30. 30. So we have what? 12 upon 5. And in the question, we were told to prove that the volume is 12 upon 5. So in the end, since we got 12 upon 5, we made sure that we prove it as 12 upon 5 pi. Remember this, when the question clearly says give your answer in the pi, you do not need to solve pi. This question was from November 2006, paper 1, question 8, question number 22 from the book. Okay, in this question, you need to understand that the first part is the area. So area, you need to understand it through lecture number 2. In part 2, it says that find out the volume obtained when the shaded region is rotated 360 degree through the x-axis. Now, through the x-axis, we need to understand that this is your equation of y, whereas this is your equation of the curve. When you have y is equal to 2, what we need to understand is volume pi integration of 1 0 2 square. This will give me the volume under the line. This will give me volume under the line, which will be pi integral of 1 0 4, because obviously we will be squaring 2. So this should be volume pi 4x. Your limits are 1 and 0. So this should be pi 4 1, obviously minus 4 0. So the answer would be 4 pi. So this is the answer for what? Volume under the line. Now you need to take out volume under the curve. To find out volume under the curve, you will say pi integration of what? Same 1 and 0. But instead, you will have 3x plus 1 half. And this entire thing will be squared. So 2 ones is 2, 2 divided by 2 is 1. So volume pi should be 1, 0, 3x plus 1. When we integrate this, we will have 3x square upon 2 plus x. Upper value is 1, lower value is 0. When we have pi, this should be 3, 1 square upon 2 plus 1 minus 3, 0 square upon 2 minus 0. Volume pi, the answer for this will be 5 upon 2 pi. So the answer for this will be area under the volume under the line minus volume under the curve. Volume under the line is 4 pi. So this should be 4 pi minus 5 upon 2 pi, which means 8 upon 2. The answer would be 3 upon 2 pi. So the answer for the volume of shaded region is 3 upon 2 pi, because volume under the line minus volume under the curve. Volume under the line is 4 pi, volume under the curve is 5 upon 2 pi. So this was question November 2008. This was question November 2008. Question 26 from the book.